So how to select a product after daylighting? There are two important parameters. One is the solar factor, another one is the U value. So how light transmission going to give a discomfort? These two parameters also going to have a huge impact on the occupant discomfort. Say for example, solar factor is nothing but it's a percentage of direct heat transfer that's going to happen into your building. U value is nothing but is going to happen because of the difference in the temperature difference. So for an example, I have a source called sun, and the sun is going to give me direct heat which is going to transfer into the building, and the same source is going to heat up my entire environment, which is going to be the ambient temperature. The ambient temperature is going to try to enter into my building where I have a set temperature. So there are two parameters which are going to hit the overall heating load in my building, which is the solar factor and the U value, or the direct heat and the indirect heat. So to calculate, so what is the impact of this heat coming in? Because in any building, when we are going to do the cooling load capacity, the two parameters which we will be calculating, one is the envelope heat load, another one is the internal heat load. The envelope heat load is nothing but the amount of heat that has been getting transferred from the external world to the inside the building through envelope. So ideally when we use glass, you have to understand what is the percentage of direct heat coming in and what is the percentage of indirect heat coming in, the sum of heat which is going to impact the overall cooling capacity. So to solve an example, I have a condition here. Say for example, you have a source which is about 500 watts from sun, and you can have a temperature difference which is 15 degrees. So I have a clear glass in a double glazing format, which is 0.73 solar factor and U value as 2.8. So when I have to calculate the relative heat gain, which is called RHG, which is the solar factor into solar incidence plus U value into delta T. So in this case, the solar factor is 0.73 and my solar incidence is 500. So 0.73 into 500, which is 365. Similarly, I have a delta T which is 15 and U value of the glass which is 2.8, which is 42. Sum of this will become the total envelope heat load, total envelope heat. So in this case, the major thing that we need to understand is what is the contribution or what is the percentage of heat transfer that happens to direct and indirect. Here the direct heat is about 85% and the indirect heat is about 15%. So when I have a glass, I need to understand what parameter I am going to address in this. If I have a solar control glass, I am going to address this 365 watts. If I am going to have a low E glass, I am going to address this 42 watts. So that's very clearly we need to understand what is the product that we need for India or precisely for Asian climatic condition. I need a glass which can address the solar factor, because which is 85% going to be the contribution due to this. To have a detailed understanding on this, I have the same typical condition, 500 watts and 15 degrees Celsius, same clear glass which is 407 watts. So when I have a low E glass or a thermal insulation glass, where you can notice the U value which is lower than your clear glass, so because of that there is an impact on your solar factor. The same formula, relative heat applied, solar factor into solar incidence, U value into delta T. So put together the heat coming in is reduced by 100 watts, still there is a scope. So we have a basic online coated glass which we call hard coated or online coated glass, where the coating is done precisely to reduce the solar factor, but you can see the U value still it is same like your clear glass. So in this case, when we do the RHG, it has reduced by 50% compared to my base case, when ideally from the base plane. Then I have an high performance coated glass, where I can address both the solar factor and the U value. So the overall reduction is about by 75%. I mean, it is ideally 1/4 of the heat is going to come in. Where it going to impact is, so when I have a simple example like this, for every 3500 watts of heat, we need 1 ton of refrigeration. Means if I have 5 to 7 square meter of a clear glass in a building, in an envelope, ideally I need 1 ton of air conditioning. If the same, I wanted to have more facade or more window wall ratio, if I use the same building with the same 1 ton of refrigeration, I can go even up to 12 to 30 square meter of glass. Still I can manage the building with 1 ton of air conditioning. So this is the impact what a clear glass versus a high performance coated glass can give. In a simple to understand, the capacity of your cooling load can be reduced when the window wall ratio is fixed. Whether I am going to use a basic glass or going to be using the first generation products or going to use the latest high performance glaze available will have a huge impact on your overall capacity of your cooling system. So what are the type of detailed study that we can do? We can do a detailed in-depth solar exposure analysis to understand which direction, during what time, and what is the intensity and how long this intensity is going to be on a building. So based on this you can decide what should be the boundary of your glass performance required. Then you can get into the daylighting analysis, which very clearly helps you to understand what is the percentage of light that you need for the particular floor plate or for the particular window wall ratio. This will help you to understand to give a comfort light transmission into the building. Third one can be your acoustic analysis, where based on the source versus what you want to achieve inside, you can clearly understand what is the percentage or what is the dB that you wanted to cut or dB that you wanted to reduce from the outside source to inside comfort level. Then for the structural analysis, we need to understand for what is the location and what height is my building and where is the building and what should be the wind load as per the IS 875 code I have to do. Then based on the support condition, whether it is all the four side supports or I am going to have a pointed supports or I am going to have only top and bottom support, based on this I need to understand for the design wind speed, for the support condition, what should be my glass combination. So a detailed study has to be done when we are going to use glass as a building material to understand the structural requirement, to understand the acoustics and to understand the performance. So how do we achieve all this performance? So called lower solar factor, lower U value, lower light transmission. As I said, there is two technology which is called the online technology and the offline technology. As the name indicates, you know that online coating is going to happen when the glass production process is happening. But this technology has a very limitation on the number of products that I can produce, because every base I have, I can produce only one kind of a product. And it restricts my performance values because the coating, I can do maximum of 2 to 3 layers of coating during this temperature, during this process, because the coating has to be done at very high temperature. That's where the entire industry has moved to an offline coating technology, where I have a provision to add n number of layers, I would say, based on the kind of product that market wanted to use in the building. So the current demand in the green buildings to have a more higher light transmission with extremely low solar factor and with a different shades requirement, it is all possible in offline. This is ideally we can make it made to order kind of products, because the market will drive you towards a particular performance requirement which has to be backward to understand what should be the kind of layers that we should adopt it to achieve the particular performance, which is possible in today's advantage with the modern technology. So as I said, online it's a first coating technology, it's a very durable coating, but it has its challenge in its limitation on the performance or limitation on the aesthetics. Similarly, when we think about offline, it is excellent. I can ideally bring in any kind of performance requirement. On aesthetics, you can have n number of options, because with one base you can develop multiple products or multiple shades. So you can have about 20 to 25 shades of blues and 25 shades of greens and grays. So it's all possible only in your offline. And all these products, whether it is an online or offline, all these products are temperable or processable, I would say. It can get into any kind of processing, whether it can be toughening, it can be strengthening, lamination or double glazing or even bending, or even doing a ceramic fretting on the glass. It's all is possible in both the technologies. So the third or the last portion, I would say, where once you know about the basic structural requirement, you have to test it as per the current wind speed. Then you have to select the product on the performance, and the important one is how to design the building for safety and security. Why it is important? Because there is a chance of human beings to impact or can be reach out to the glass at any point of time when the current envelopes are with glass. So there are codes like IS 16231, which is launched in 2016, which has part 1 to part 4, which clearly in a very detailed manner helps us to understand based on the critical locations. For example, critical locations like your facade, where you have to check the critical locations like whether the glass is going to be vertical, whether the glass is going to be inclined, or glass is going to be overhead or the skylight, or whether you are going to use a glass for the floors or for connecting bridges. So it helps you to understand based on the critical location what kind of glass is to be used, and ideally it's called safety glass. So in this, the safety glass means the glass which can withstand human impact. That's what very clearly says in safety glass, but it doesn't mean that this glass going to give you the other safety against your human or bulletproof, or it cannot behave like a glass against vandalism or forced entry. So in this chapter, in this IS 163, when we say about safety glass, it names only two glass or two processed types of glass as safety, which is ideally the tempered glass or laminated glass. In this lamination, the options is open whether I can do a toughened lamination or I can do a heat strengthened lamination. So only these two glass has been named as a security or safety glass. So in case of security requirement, we need to understand what kind of security I am looking forward, whether it is a simple forced entry, or it going to be a bulletproof, or it going to be an explosive resistance. So based on this, there are kind of products and the kind of level that I wanted to look forward, and the kind of testing it has to pass through to adjust to the requirement, then I have to use a glass. So there are two different things in this. One is safety, another one is security. Safety means human impact. So ideally it has to be toughened or laminated glass, which can be toughened lamination or heat strengthened lamination. When it comes to the security, default it has to be laminated, but what is the glass thickness, what is the combination, what is the number of, how many number of layers it has to be, and what kind of material it has to be, it has to be decided based on the kind of security we are looking forward and purpose for it. So these kind of pictorial representations are there in the IS 16231 to understand where the glass is going to be and what kind of glass has to be used. Say for example, we have an access in the picture where we have an access to touch the glass. In that case, it very clearly says it is safety and tempered glass. Whereas as a next option, when I have a chance that glass is above my head or it's inclined or even in the handrails, then it very clearly says it has to be laminated safety glass. It cannot be a just simple toughened glass. So to recap it, what we have gone through this today's session is, we need to understand how we have to use glass and how to understand glass. First, we need to understand glass by its design. Design in the sense, what is the purpose and where I am going to use and how I am going to use. Then we need to do a simple analysis on the energy requirement and the light requirement, so that you will be very precise in calculating what is the solar factor, U value or light transmission requirement of the glass. Then what is the need, where I am going to use the glass, whether it is going to be an envelope material or a partition or going to be any other functionality. Then what is the kind of benefit I am going to expect from this material, whether I am going to use this as just an envelope material or as a security element or as a material which is going to cut the amount of noise coming out, which is an acoustic barrier. So unless I understand or clearly define my benefit, then it would be a challenge later to understand this material. And by function, what is the functionality of the glass I am going to look, whether it is going to be static or it is going to be dynamic or it is going to be expressive like dynamic facades. So unless I have to incorporate all this in the basic design, in the basic process of glass selection, starting from the design, analysis, need, benefit and function, glass cannot be utilized or cannot be used as an effective envelope or effective building material. So with this session, we will understand the glass, how to use or how to design glass as a building material.